Review. Let me explain this. So I want to go through some problems today. It probably take us pretty much all period, but today's a short period. What that buys you is tomorrow it buys you a work day. So, and then get questions answered, and then we'll go ahead and do the Unit 2, Test 3, the final test we'll do on Wednesday. All this is really nothing new. It's just pulling stuff together we've already talked about within the context of being strategic. So half the questions on the test are going to be multiple choice where you're picking the right strategy, and the other half are going to be you're actually just solving quadratic equations using, hopefully, the best strategy, right? So let's do both today. We'll take some of these problems and we'll identify what the strategy is going to be, and then we'll go ahead and finish it up and solve, get a little review, practice, actually solving quadratic equations, okay? Okay, so what about this guy right here now? Let's just kind of, let's share the opportunities here, and everybody contribute a little bit. What's our thinking on this?
Complete the square.
Complete the square, good. And why is that? If we look at the options, we're kind of always going to start with the easy stuff and work our way down, right?
Because x is
We can't isolate x, how come?
equal.
Multiple x's, right? We can't point to a single x, so that's off the table. Factoring and zero product property. Well, what would the magic numbers have to multiply to?
6 and a half to 14.
They'd have to multiply to 6 and add to negative 14. Do those numbers exist? They do not. So we can't find magic numbers, so we skip that. Now, why is it that completing the square works well?
X squared is positive and
It's even.
x is even.
Okay, good. There's two parts to this.
Or x
So-
squared is equal to 1.
So A is equal to 1, right? So there's two things happening here. A equals 1, which is good, and B is even. Right? And so that's a recipe for completing the square, right? Now what I want you guys to do though, so we're going to go through this, we'll go through the process of completing the square. But I want to take extra care today to try to get you away from just memorizing and more towards synthesizing, right? We want to move, the higher the depth of knowledge you understand a concept with, the more you internalize it. Be honest, how many people, because this happened to me a million times, how many people in classes have, they had a deadline for a test, they studied for the test, within a week it's gone, right? It happens all the time. What kinds of classes does that typically happen? Math. Well, we'll try to fix that. But I would say it would happen more often than not. I would tend to suggest that probably happens in classes where you have to memorize a lot of information. Right? When I say information, that's almost like code for facts. Right? I mean, for me, it was, if I had to, like with history, you're just memorize, a lot of times you're just memorizing discrete little facts. Those are not strongly held in your brain. It's not the way the brain works. Right? When you're talking about memorizing facts, facts are only held between a small number of points in your brain. The network is not very expansive. It doesn't spread out throughout your brain. But when you start to take information, and this is the best way, this is the secret. I swear to God, this is the secret. Or if you're going to be successful in high school and college and beyond in your classes, you've got to just find ways to do this trick, right? To attach the information more strongly than just flashcards. So you want to get out of the flashcard mode and get into the concept mode, and then things stick forever, or almost forever, right? So that's what we want to do when we actually complete the square. So let's go through that process. Now when we complete the square, we're starting here. And we kind of started off maybe memorizing a few things, right? We started off, we've always talked about what our starting line is for completing the square, right? We always wanted to get it into the form x squared plus bx space equals a number, right? Well, what does that amount to here?
X squared minus 14 equals negative space equals negative 6.
Right, so we're going to subtract the 6 to the other side, right? Now let's start to think about this, though, in terms of why we're actually doing this instead of just memorizing a process. Right, think what we're doing here. X squared minus 14x equals negative 6. The whole point of this The whole point of completing the square. If you grasp this, it makes it so easy to remember and execute. The whole point of completing the square is we want to add whatever number I need to both sides so that this expression factors. And it factors so that the magic numbers end up being the same number twice. That's it. That's a convenient way to make things factor, right? So what's that going to look like then? When I have something squared here, it just means that I have the same factor times itself, right? Everybody get that? So what is the magic number going to be? Now we know that it has to multiply to whatever goes there, and it has to add to negative 14. Think about this logically. If I want my magic numbers to add to negative 14, then I want them to be the same number. What number do they have to be? Negative 7, right? Because wouldn't that make sense that each of them is just going to be half of b if they're together? The two magic numbers are going to add up to b, and each one has to be half of b, right? So you already know then that the magic numbers would have to be negative 7 and negative 7. There's my negative 7 squared, right? X minus 7 squared. So now if I want those to be the magic numbers, I have to fill in this blank though. The number that we have to start with up here, the numbers would have to multiply to this number and add to this number. Well, what would that number have to be? It's got to be 49, doesn't it? Because my magic numbers we already know are negative 7 and negative 7. And negative 7 times negative 7 is just negative 7 squared. That's 49. That was pretty tricky. Look what we did, right? We picked the right number so that the magic numbers worked out to be the same number twice. Okay? And why did we push the negative 6 to the other side? Because we wanted to start from scratch on the left side. Right? We want to have a blank slate there so we can pick just the right number that goes with negative 14x. Everybody get that? So then on the other side, you know, whatever we're left with is whatever we get. If I add these things up, negative 6 plus 49 is what? 43. You see the benefit? Look what we did strategically. By making this something that factors into the same magic number twice, so we get x minus 7 squared, which kind of a problem have we bought ourselves now? What's our strategy going to be from this point forward? Yeah, the easiest one, right? The top of the list. We go from easiest to hardest on that list. By completing the square, we go right to the easiest method then. See what I'm saying? And then what are the two steps to isolate x from that point forward?
Square root at 7.
Square root at 7 and we're done. You get it? So there really is a method to our madness here. There's a concept behind this that makes sense when we're completing the square. Okay? So we end up with, then, if I square root both sides, x minus 7 equals plus or minus the square root of 43, and we just add the 7 in front, and so we get x equals 7 plus or minus the square root of 43, and there's my two answers. Okay? Make sense? Okay? How about one like that? What am I going to do with that guy? Before I can do anything, I don't even have a good place to start. What do I have to do first?
Push everything on the left to the right to make everything positive.
Everything on the left to the right?
Or right to the left.
Right to left, because I want my x squareds, I want to have a positive number of x squareds. Right, so all this stuff, we're going to push it to the other side by adding that term, and adding that term to both sides. Agreed?
Just factoring this as zero product property.
So I'm going to get 2x squared plus 16x, and then if I add 10 to negative 10, they cancel. Agreed? And so I get that. Okay. Now let's think about that for a second. So that's much better, right? We put it in standard form. I've only got two terms. Remember, if I've got two terms, I will never have to go further than the first two steps. That's it, right? I'm always going to directly isolate the variable if I can. Can I isolate x here?
No.
Can't. Everybody agree I don't have a single x I can point to. But that, all that means then is I'm just gonna factor, and by factoring it means factor out a GCF, the greatest common factor. Okay? So let's look at that. Now, let's see, Stephanie. So our goal here is to find the greatest common factor. 2x, exactly. Good, we want to break it into a number part and a variable part. What's the biggest number that divides into 2 and 16? It's 2. But x also, I could divide each of those terms by x. Everybody agree? Because they all have x's in them. So my greatest common factor is 2x, and if I want to see what's left over, all I have to do is divide each of these original terms by my GCF. If I divide 2x squared by 2x, the 2's cancel, right? What's x squared over x? X, right? So I end up with x plus 16x over 2x, the x's would cancel, and I get 8. So it factors, right? And now all I would have to do is just set those factors equal to 0, right? Because look what I've got. I've got factor number 1 and factor number 2. I'm just going to set each of my two factors equal to 0 and solve to find the solutions then, right? Because I'm using the zero product property. Factor 1 times factor 2 has to equal 0. That only happens when either factor 1 is 0, or what's the value of x that's going to make factor 1 equal to 0? 0. 2 times 0 is 0, right? Oh, it's bad x. So x equals 0, or how about this guy? There we go. Okay. What do I have to do here first? Add 15, good. So that's going to give me, I'm going to cancel on that side. I'm going to get negative x squared minus 16x minus 60 equals 0. Now, Ashley, that doesn't look quite right yet, though, does it? What else could I do to that to make it better? Good. Multiply both sides by -1 to change all the signs. Very good. So that's going to become x squared plus 16x plus 60 equals 0. Okay, so Brody, what's your thinking on this? Can I isolate x? Cannot. You're correct. What about the zero product property? What would the magic numbers have to multiply to? 60, and they'd have to add to. So those numbers exist, don't they? What are those? 10 and 6. Okay, but those are not my solutions, right? Those are just magic numbers. What are the solutions going to be?
-6.
Okay, good. Okay, what's that one going to be? It's pretty easy. Directly isolate. There's a single x I can point to, and so I isolate it. What would the steps be?
Add 10, divide by 3, square root.
Everybody agree? Add 10, divide by 3, and square root in that order. Okay. You want to do that one, or raise your hand if you want to finish that one up. You want to see that? Okay. Figured probably maybe we're okay with that. That's fine. What do I have to do here? Jaden, what do I have to do here before I can do anything?
We get 6x.
Good. So we'll subtract 6x from both sides. That goes away. So x squared plus 9x, right, plus 26 equals 0. Okay, now we got some thinking to do there. Peter, what do you think? Can I isolate x? Cannot. You're right. What would my magic numbers have to multiply to here? 26, because they'd have to multiply the 26 and add 2. Is that going to work? There aren't any numbers, so we skip that. Is completing the square a good solution? You're right, Josie, how come? B's not even, right? B is odd. So that goes away. So what do? Quadratic formula. There you go. So what are my values here of A, B, and C? A is
1,
B is
9,
C is
26.
good. And we know the quadratic formula. If we start off in standard form, which we are, right? Then we always know, guaranteed, our solutions are given by the quadratic formula, which is x equals
b plus or minus square root of b squared minus 4ac divided by a.
And when we say divided by 2a, remember, we mean the division bar is the whole thing divided by 2a, correct? Okay, so then we've got to just plug and chug, and we're good. So we get x equals negative b, well, that's going to be what? Negative 9.
Plus or minus the square root of 9 squared minus
So what's 9 squared?
81.
81, good. Minus 4 times a, which is 1, times c, which is 26, all divided by 2, right? Good. So all we need to do is just simplify that. And the quadratic formula, the simplifying occurs inside the radical. That's where all the action happens, right? So we end up with negative 9 plus or minus the square root of 81 minus 104. Well, what is 81 minus 104? Negative 23. Everybody agree? All divided by 2. And so really there's only 2 more things we got to do. What do we always recognize? If I have the square root of a negative, I'm getting an I outside, right? An imaginary unit outside. So then we can break this into 2 parts, right? We want to split this thing up into not a common denominator. We want to break it up into 2 parts. So we're going to end up with negative 9 over 2 is negative 9 halves, plus or minus. And then this part right here is just going to end up being the square root of 23 over 2 times I.
Doesn't the square root go away once you put the I in?
No. No, because the square root of negative 23 is really just the same thing as the square root of positive 23 times the square root of negative 1. And the square root of negative 1 is what we call I. Okay? Make sense? Okay? So there's our 2 answers to that one. Of all the ones we've done, that's probably the hardest, isn't it? To me, I mean, the quadratic formula, it's a guaranteed winner. It's all you got to do is plug and chug, but simplifying, you got to be careful with it, is all, right? So you can see why, does it make sense strategically, why we'd always prefer to avoid the quadratic formula if we can, because there's less of a chance of making a mistake if we have an easier method, right? Okay, continuing on here. What about this guy? We won't necessarily get through all of these, but we'll get through as many as we can. What am I going to have to do here? Regina, what's the first thing I have to do? So from right to left, good. So we'll subtract 80x from both sides. We'll add 290 to both sides. So all that cancels. And then I end up with 5x squared minus 15x minus 80x is minus 95x. 160 plus 290 is 450. Okay, that's better. Can I make that easier still? Right? Do you see anything else there I could do to make that easier? So, okay, because it's an equation, let's just divide both sides by 5, right? 5 is the greatest common factor, but let's just divide each side. Because it's a number, it's not a variable. Let's just divide each side by 5. We can do that with an equation. multiply or divide both sides by the same number, right? So that's gonna give us 0 on the right. On the left side, we'll just divide each term by 5. Well, 5 over 5 is 1 x squared. Negative 95 over 5 is negative 19x, right? We end up negative 19x. And what's 450 divided by 5? 90. Okay, so now let's see here. Skylar, let's talk, what's the best method then? What do you think? Let's just go down the list. Can we isolate? No. Can we factor?
Oh, yeah.
We can actually, can't we? Numbers have to multiply to what?
90.
And add to. Okay, so my suggestion is when you're actually doing the factoring then, write out the brackets. It just seems like it's easier to organize. So we get x and x. Yes, Dee? Yeah, you bet. So what magic numbers, and let's play the sign game. If they're gonna multiply to a positive and add to a negative, what would the signs have to be? Both negative. And what numbers multiply to 90 and add to 19? Okay, good. So what are my solutions then? Okay, good stuff. Okay. What would that one be? Isolate the variable. Good. Right? We can see right away here that I've only got a single variable, so I'm just going to isolate it by reversing order of operations, right? So what's that give us? Negative 3x minus 5 squared plus 10 equals 108. What are the steps I'm going to do first? What's the first thing I got to do to get the x by itself? Subtract 10. Good. So that gives us negative 3x minus 5 squared equals 98. Now what? Square root. Okay, and what about 98? Can anybody think of a really smart way to factor this? Is there a big perfect square factor? Say it again. Not 34. You're on the right track though. What is it? 49. Aha. So we could make 98 break up into 49 and 2, and 49 is a great choice because it's perfect square. So we get a couple of 7s and a single 2, right? There we go. So we end up with negative 3x minus 5 equals plus or minus, right? 7 radical 2. Now what are the last two steps?
Add 5, divide both sides by 3.
Good. So add 5. Now what are we going to divide each side by?
Negative 3.
Okay, but we got to be careful with that, right? Right? Got to be careful. I'm going to divide, when I divide each side through by negative 3, I'll divide the first part by negative 3, but because I've got a plus or minus there, what am I going to do?
Just leave it as 3 because
Everybody agree? We never divide a plus and minus term by a negative because we already have both signs. So we'll just divide by 3 to make it simpler. And we end up with x equals 5 over negative 3 is just negative 5/3 plus or minus 7 radical 2 over 3. I can't simplify that. 7 over 3 doesn't reduce, right? Okay, so what's next? Let's see. There we go. Okay, what about this one? What do we got to do first? Subtract 7. Good. Okay. So if I subtract 7, I'm going to get x squared, that x, minus 6x plus 11 equals 0. Anna, what do you think about that one? Can I isolate? Can't do, I've got two x's, don't I? So I can't isolate. What would the magic numbers have to multiply to? 11 and add 2. Does that work? No, no magic numbers. So would I complete the square? That works, doesn't it? Tracy, why am I completing the square? It's a good strategy.
I don't know.
Okay, it's, so we couldn't find magic numbers, but something about this said it's a good, Emma, do you know what it is? What's? B's even, right? There's the key. So we end up with A is equal to 1, and B is even. So this is a great candidate for completing the square. It's easy to do, right? So we complete the square. What would the steps be then? So we're going to subtract 11. So x squared minus 6x space equals negative 11. So we got to add just the right number to both sides so we get magic numbers that are the same number twice, right? What's that magic number going to be? What's that going to be? Chelsea? Negative 3. There you go. Which means, what did that number have to be? Had to be 9. Now it works, right? Magic numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. And then on the other side, negative 11 plus 9 is just negative 2, right? And now we're essentially done. We just square root both sides and add 3 and we're done, right? And so if we do that, by square root, I'm going to get plus or minus the square root of 2, right? If I square root, I've got a square root of a negative, of a negative. So I've got an I outside the radical, and then I'll just add the 3 in front of the plus or minus, and we're done, right? Okay, is that good? All right, everybody, what's that one going to be? Isolate x. We won't do it. We've had a little practice with that already. But we'd isolate x. What's that one? What am I going to do there?
Yeah.
No, maybe. But first, what do I have to do?
8x.
Move 8x to the left. Or, what else could I do? Because I'm going to end up with a negative a, and I'd have to multiply both sides by negative 1. I could move all this stuff. This is a little different way of thinking about it. But I could move that stuff to the right this time, right? Yeah, so that's going to give me 4x squared. I've already got an 8x there. I'm going to add a 40. And it's equal to 0. We probably put the 0 on the right side, though. Why not? Right? And now what can I do to both sides there? Meaning I could just divide both sides by 4, right? And if I do that, I'm going to get 4 over 4 is 1x squared, 8 over 4 is 2x, and then 40 over 4 is 10. Let's put the 0 on the other side. And what's my strategy going to be that time? What do you think? Paul, what do you think? What would you do there? So you're thinking complete the square. Good, right? That's it. We can't isolate x. There are no magic numbers that multiply to 10 and add to 2. So we would just complete the square, wouldn't we? Right? Complete the square, which would mean we'd subtract 10 to that side and then fill in a bunch of blanks. Okay, we've already done that though, so we'll maybe skip that. Let's see, one more. What about this one? Okay, what do you think? Move everything to the right. Good, so they're positive. I like that. So all that stuff, we're going to kick to the right. And that's going to give us, if I add 3x squared, I'm going to get 3x squared. If I add 45x to negative 12x, 33, good. If I add 66 to 57, I get 123. and all that's gonna be equal to 0, right? Okay, so, let's see, Madeline, any ideas here? Anything that could make that a little simpler? What could we do? Divide by 3, perfect. If I divide each side through by 3, then I'm gonna get x squared plus 11x plus 41 equals 0. We can already pretty much tell. Am I gonna get magic numbers? No, I'm not gonna wanna complete the square because that's odd, so what would I do?
Quadratic equation.
Quadratic formula, right? So we would go here. And then last one, we won't do it, we'll run out of time, but same kind of thing here, everybody agree?
Yep.
If I subtract 12x, or I add 12x to both sides, I'm gonna get 2x squared plus plus 14x. Plus 29 equals 0. Well, now this time, can I divide both sides by 2?
No.
Doesn't work, does it? And so anytime, this is a dead giveaway, anytime I'm stuck with a not equal to 1, what do I automatically do? Quadratic formula. Exactly. Whew, that's a lot of math in a short period. Does that help? Okay. All right, so you got a work day tomorrow. You got 2 assignments up from 2.6. First one's about strategy. Second one's about solving equations. You can get questions answered, and we'll test Wednesday.